What is going on YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 12, Problem 11 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 12 is all about equilibrium and elasticity, and in Problem 11 we have a meter stick with a couple of coins on it that's being balanced, and we're asked to find the mass of the meter stick. And so with this problem, drawing a picture is actually extremely useful, so I'm going to take some time to do that really quick. And so we have a meter stick that's balancing, so we'll draw a balance with a meter stick on it. And we also have two coins that are balancing right here, so we'll just draw two boxes, and those will represent our coins. And so what we can do is I'll define the length across the meter stick from this end, and so we'll call the length to the coins L1. We'll say the length to the fulcrum here is length 2, and then we'll call the distance from the end to the center of the meter stick length 3. So we'll say that's about right there maybe, and so that's length 3. And now, since this is balancing, we know that the sum of the torque around this fulcrum is equal to 0. And so we can say the sum of the torques is equal to 0. And we also know that torque is equal to force times a radius. And so what we can do is we can essentially just do a torque balance on this meter stick. So we have 0 is equal to, we'll start with the coins, and so I'm going to define counterclockwise as the positive direction for the torque, and so the force of our coins on this meter stick is going to be the weight force of the coins, and in this case there's 2, so we can say 2 times the mass of a coin times gravity, that's our force, times the radius, which in this case the distance from our coins to the fulcrum is going to be length 2 minus length 1, which gives us this distance here. So times length 2 minus length 1. And then we also have the weight force of the stick itself on the fulcrum, which is going to be right here at the middle. And in this case, this force will be acting in the clockwise direction, meaning that we have to subtract it, since we define that as the negative direction. And so minus the mass of the stick times gravity, and then times our radius, which in this case is going to be from here to here, so length 3 minus length 2. And now we have our balance completed, and we're looking for the mass of the meter stick. And so what we can do is we can take this whole quantity and add it to the other side, and so we get the mass of the stick times gravity times length 3 minus length 2 is equal to 2 times the mass of a coin times gravity times length 2 minus length 1. And so what we can do is we have gravity on both sides, so we can cancel those out. And we're also looking for the mass of the stick, so we can also divide by length 3 minus length 2. And so we get that the mass of the stick is equal to 2 times the mass of a coin times length 2 minus length 1, all of that divided by length 3 minus length 2. And we actually have all of those values given in the problem statement, and so we have 2 times 5 grams times 45.5 centimeters minus 12 centimeters divided by 50 centimeters minus 45.5 centimeters. And if you plug all of that into your calculator, you should get that the mass of the stick is equal to 74.4 grams. So that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.